Hello, everybody. Welcome to this talk. Things I wish I knew when I was a student Android developer. And thanks for tuning into this talk when you are in between a hackathon. I was there. I was a student, so I know how hard it is to come out of a hackathon with all that rush and then coming into a talk. So I hope I won't take my longer time in this thing. So just a quick intro about me. Uh, so I'm Yaswant Narayan, as the YouTube title says. Cool. I am currently working as an Android developer at Zomato, and yes, I graduated from VIT this year, the 2020 during a pandemic. That's the thing. So I've included my Twitter and LinkedIn links here. So in future, like if you want to reach out to me or if you have some suggestions or whatever, please feel free to ping me. So this is what I'm going to talk about today. There is no specific order in this thing, and these are not the only things that I wish I really knew when I was a student developer. But I feel this is something kind of basics that everyone should know when they are learning Android development from their college life. So this is what I wanted to share today. So let me get into the big thing, context. Context, the very first thing I'd like to talk about context is because we all think context is kind of a magic, because wherever we need context we just pass it and it just works, but we never really understood what context is really. And so I wanted to explain a bit more about this. Basically, context is like a global state of information of your application. So imagine you go to a new place and then you don't know anything there. So you randomly call a person and you say, hey, give me a context about what's happening here. So that's exactly what context is doing. So it tells the OS that this is the state of the application and this is how it needs to be rendered and blah, blah, blah. That is context. There are a lot of types of context that people need to know, but for us, two types which is really important is application context and the normal context that we have. So going on to the application context, it's a long-lived context, I should say, and the normal context is limited to an activity or a service that is running right now. So that's why we have application context, which spans across all the screens of your app, and context is just to one screen. That is the main difference that we might need to know at this point, and nothing more than that. So where all do you have context actually? So the activities, services, and there are like 60 plus classes that actually extends context. It doesn't have context in them, it actually extends from context. That is why inside activity, wherever we need an what to say context, we just give this reference, like the self reference is we give inside activities is because activities by default extending context. That's why we give this reference inside activities. Views is an interesting case actually. The Android view doesn't actually extend from context, but you can't actually create a view without a context. So views always have a context, doesn't mean they're inheriting from context. So this is the difference between that a context when you use an activity and when you get it from a view, and so on and so forth. So one very big thing that we usually do is we pass in context wherever it is necessary. Just like that, we store context, I mean, in variables and whatnot. So we should actually try avoid doing that, because context is a really heavy object. As I said, it's a global state of information, and Android OS apparently needs a lot of information about our application when it is running. So uh, it context is like a very heavy application. Even when you have a simple bitmap image in your activity or in your screen, so those, like this bitmap matrix, for some reason it is held by context for memory utilization and stuff. So context is very heavy object. So You can pass it in methods, but don't pass it as a like what to say, store it as a global variable in any class. If suppose you want to do that in a very bad situation, use a class called weak reference. I mean, I'm not diving into a lot of deep concepts today. I'm just giving you an overall look about what all that you can explore later on. So explore about weak reference in future when you have time. And like, why do we even need context as a developer? Like, okay, Android system needs context for application. Why do we need context? Why do we need to use context? It's because of all these functions that it has. Get resources. This is basically what can I say? Getting string resources, string colors, dimensions, and etc. Getting assets is getting files that we have stored. And system service is very important. Wi-Fi manager, location manager, these things are the Android system service. You just can't use this class Wi-Fi manager. You have to request the service using a context. So these kind of things. And we have start. So you can start an activity, you can start a service, you can start a broadcast receiver. And context also holds theme information. So our application theme is held by context only. So that is why the views also need context. So I can conclude about context by saying it is required for majorly two things: accessing resource from our application or accessing resources from other application. Like for example, you give an intent and it gives like a result back, something like that. So basically this is where we need context. So that's all we need to know about context. Let me get into another thing. Android X, very familiar nowadays. I mean, it was familiar anyway, but cool. The reason why I wanted to talk about Android X is we all use them day to day, but uh, it's like I've seen a lot of people who misunderstand what Android X is actually. So I would just simply say it's a set of library which makes our life easier. Yes, supposedly it is supposed to make our life easier, but one minute. So but it does have a lot of learning curve, I would say. But at least it really does make our lives easier. I'll tell you why. So there are two things that we have something called Android X, which is previously called support libraries. So one is backwards compatibility and a lot of utilities and helpers. So the important thing is backwards compatibility. It's because every Android version when it is released, it is having a lot of changes. And for example, a very big change for once happened when from Android KitKat it went into Android Lollipop, and that time material design was introduced. We had all these fancy new components like side navigation, tabs, and app bars and bottom navigation, whatnot. So those things actually were once supported in KitKat and previous versions. So Google had to do something to support all the backwards like the previous versions of Android. And so that's when they released this support libraries, which is now called Android X, a namespace. It's just namespace for all the libraries which was under support libraries previously. And it also has a lot of utilities and helper classes which helps us in day-to-day life. Actually, now, like previously when it was support libraries, there was very few. Now that when Kotlin was introduced, and then like they moved to Android X, there are a lot of extensions, functions, and lot of utilities helpers are there. Like you might have to explore a lot about what Android X gives you when you're like when you're doing Android development. That really helps you. By the way, recycler view is considered a utility. We use that like literally every day. And recycler view apparently is a utility class. Cool. So the one important thing about this is this Android X library, Android X namespace libraries doesn't get shipped with the OS itself, and so we get very quick updates. Imagine if it would have been coming with the OS itself, we get a library update every 1 year. So that's bad, isn't it? So now we get updates every week. So that's because it's not bundled with the OS, and the development of these libraries happens separately. That's about Android X. Let's get into app architectures. This has, like, for the past 2-3 years, I would say, is gaining a tremendous attraction nowadays, I should say. app architecture is something we usually, when students developing apps or something, we don't really care much about it. It's a thing with companies actually. So when you start working, you will be asked to learn software architecture and implement that. But for some reason nowadays, even when you want to start a very fresher role in Android, you need to know some kind of app architecture. So before getting into app architecture stuff, so I'll tell you how we used to start writing. I guess most of us would have gone through this, where when we start building our first app and then we start to add more features in one screen, all the code, literally all the code goes into one file, like one class, which can be a main activity or something. So that we call it a god class. Basically you write thousands of lines in just one class and you make it a god class. But so in architecture principle wise, what we can say is we need to separate our codes into a lot of components. So these are the components that we can separate our app into. So any typical app that we mostly build will have a network related code, will have caching related code, it will have UI related code, and then something comes in between called business logic. So this network and this database and this UI, if we separate it out, then what is really happening in between? What is controlling all these three things? That is the business logic. So I'll explain more about how these things are connected together. Before that, I'd like to show you what are all the different architectures that we have as of now. I mean, these are just a few famous app architectures. If you just Google software architectures, you'll get hundreds of them. This has been done, like previously followed in the Android community ever since Android was launched. So initially they used to have something called MVC, the model view controller, and model view presenter came in, and it had a lot of issues. And recently, just a few years back, Google came up with an architecture called model view model. Though I'm not going to explain what model view model is, because that itself will take a couple of talks. I'll say it's a very big architecture, you need to understand a lot on that, but I'm just leaving it to you to explore that. This is just a guide I'm giving you. These things you can explore, but I'm telling you what these architectures are. You might have to look into these things. Nowadays Mvvm is a thing to know for everyone, literally. Even for a fresher and a developer, they expect that you at least know what Mvvm is, even if you have not worked on that. So before Mvvm, I have something called clean architecture. That is what can I say, it's an very old architecture apparently, that if you want you can explore and you can add it. Mostly people won't use that. It has a lot of ceremony to be done before implementing that, but cool. So let me go and show you how the basics of all these kinds of architecture, how does this even work. So as I told you, we have this network related code where we make API calls to servers and whatnot, and we have caching. Caching can be your databases or even shared preferences. Some people use it in caching layer and everything. And we have this user interface. That's where your activity and fragments and everything come. So this is where business logic comes in. So the business logic layer of your architecture is what is going to combine the what to say, or orchestrate the user interface, network, and caching layer. Okay, so I was talking about MVP, MVC, MVVM. So what is that MV and that the other whatever comes after that they really cover? So model is basically your data source. It can be your backend giving you data, or it can be your local database giving you data. So that comes under model. And all your user interface, as I told you, activities, fragments, your custom views, whatever, that comes under view. And your business logic layer, this is what people call either controller or presenter or view model or whatever. So the name of this business logic layer depends on what architecture you choose and you decide to implement. So I would like to conclude architectures by saying it helps you write scalable, maintainable, testable code. These three things you should always keep in mind. It's like a mantra, you can say, like scalable, maintainable, testable code will always help you grow as a better software developer, like that. So that's up with this. And it's an interesting topic that I'd like to discuss here. It's the dependency injection. Okay, it's really not that syringe there. Just put that. Okay, so dependency injection is nothing to, it has nothing to do with Android at all. But again, along with this architecture, that is also gaining a lot of traction nowadays. Dependency injection is becoming a thing in Android development world. So I believe this is something that people need to know even when they are learning Android. Usually I've never seen places where they teach dependency injection when they are teaching Android itself. So I thought maybe you could, if I can introduce this to you, you can go ahead and explore what dependency injection is and stuff like that. So as it is said in the slides, it is a general software design pattern. So see, the thing is I have to explain it with an example, otherwise you wouldn't understand. So let me go with this. Imagine you have a car and you can drive a car. Cool. But can you drive a car just like that? Probably you need an engine and you need set of wheels for car to drive. This is purely hypothetical, and don't flood the comments by saying car needs a lot of stuff to run. Just hypothetical things. And so yes, we go ahead and create an engine, we go ahead and create a wheel and everything. Cool. So now check this out. So now our car has engine as well as wheels. That's so cool. We got our engine wheels. Now if you call this drive function, the car's gonna drive. Yes, that's awesome. But over here I'd like to tell you one thing, that for this car class, engine and the list of wheels is kind of a dependency. So this car class is depending on engine class and car class is depending on wheel class. So, and we are initializing the dependencies inside this class itself. Again, engine is a dependency, wheel is a dependency, and we are initializing it here itself. But dependency injection tells us to do this. So whatever your dependencies are, don't ever create it within that class itself. Try to get it from somewhere outside. For example, over here I have got this engine and wheels as a constructor variables. I mean, what can I say? In constructor itself I'm getting the engine and wheels, so I don't need to worry about how to create the engine or how to set the wheels and stuff like that. So basically this is what dependency injection, this is where dependency injection comes in. Basically someone else creates stuff and then injects it over here. So that is the engine. So the car doesn't need to worry about, hey, I don't know how to make engines, just give me one, I don't care. That's the thing. That's the thing with dependency injection. So like in words it might sound easy, but I'm telling you, if you want to do that manually, dependency injection, you would hate yourself. So just go with libraries. Battle tester libraries are out there. So a very famous library is Dagger. Recently, like very recently, I guess weeks ago, there was something called Hilt, which was built on top of Dagger. So Dagger is a library which was created by a company called Square and then got forked by Google, and then Google's now recommending it just because they're contributing to it. And Coin is another library. If your project is 100% Kotlin, and then you can just go ahead with Coin if that doesn't bother you. It's very easy to use library. I'd say this about dependency injection. Now let's get into testing. Yes, this is something most of the students really leave behind when they are learning Android development, or I should say no one was really taught about testing very well. So I really wish I knew about testing when I was a student, so that's why I'm just adding it here. Well, testing is not just testing the app's flow. I mean, you can't just take your phone and then no, this button is working, this is going to this screen, cool. That is not working. The testing means I talk about software testing, like this unit testing, integration testing, and UI testing. So that's like we write code to test our code. Like you don't believe your code, but again you write a code to test your code, like that. So this unit testing, integration testing, UI testing, probably you might not have heard about it, or you might have heard about it but you don't know what that means. So for this thing, there is this not so very infamous Android test pyramid. So this is very important. Right now this might not make some sense to you, but when you're exploring testing, this is like a really helpful thing for you to remember. Unit tests are something very small. Mostly it tests only one particular class, and there are a lot of unit tests in your code. That is why it is at the bottom of the triangle. It is There has to be a lot of unit tests, and the libraries you can use for unit tests are also mentioned here: JUnit, Mockito, PowerMock, and stuff. I'm not going to explain about those library. Like it's going to be a bit overwhelming when I explain those things. And integration tests is when, if you remember in app architecture, I was explaining about how the different layers of app we have, like the UI layer we have, and then the business logic layer, and then the network layer. Imagine you want to test how business logic layer and then the network layer, how do they glue well together. You want to test that, and then you go to integration testing and you use a library called Robolectric. And then you have something called UI tests. This is like it's a very fun to write test, because this one runs on emulators. Like all the other two tests I told about, it runs on your laptop, but the UI test runs on either your phone or your emulator. It's like you write code to do that manual testing that I was talking about. Like when you click this button, it goes to this screen. Over there you scroll down, and then you have another set of buttons to click on. So that kind of thing you do in UI test, and then you see that your app automatically just moves on, and it just clicks here and there, and then it just works. That's really nice to have. I'm just telling you, these are the 3 tests that an Android developer needs to know, and the libraries are mentioned there. So maybe you can explore more about that, or ping me, I'll help you with that. Multi-threading. Yes, multi-threading is something which took time for me to understand properly. That's why it's like, and then after realizing, it's like, oh my god, that's such a mind-blowing thing. That's why I have this mind-blowing emoji. Cool. So let me get into what multi-threading is. Basically, multi-threading is in any, like not just Android, in any kind of software development you have. Multi-threading is you run a very expensive thing on something like a new thread which is off the main thread, which is not the main thread. You don't run stuff on main thread. Okay, so before continuing, I'll explain what main thread is itself. So that will be a bit helpful here. Let's say you have this app drawer, and then you click on any random app, and then the first thing that the Android is going to do is start a process for you. So it might be like an OS class for you right now, but please bear with me for a while. So this process is started, and inside this process is where a main thread is started right now. So basically, you click an app, a process for you is started. Inside the process is where your application is running, and then there's only one thread where your code runs initially. So make sure that remember this point where your code runs initially. For example, all the activity on create, on destroy, or like other functions that you chain up in those things all run on main thread. And this is where even the Android UI rendering stuff is also happening. A lot of things are happening on main thread. Even your code runs on main thread. So now I've explained what main thread is. Why should I even do CPU expensive task away from main thread? Why do I have to create a new thread and I have to do that? I mean, even I was kind of asking this question for myself. It's like, nowadays the phones are getting faster and faster. Why can't it just run on single thread? Anyway, you can just do it in one single thread. But why not? So there's a simple math behind that. So I'm going to explain that to you. Imagine our phone screen has like 60 FPS refresh rate. That means in 1 second 60 frames are shown. So Android OS is like making sure that 60 frames are like moved in just 1 second. Now we will come to every frame. So every frame has 1/60th of a second to render its views. That means whatever that screen that you're designing, it has to render in 16 milliseconds. That's the time you get. Imagine within 16 milliseconds your code has to run, and it has to let the Android OS draw the entire view hierarchy of your activity in that screen. So that is a 16 millisecond. But again, 16 millisecond doesn't mean we get 16 milliseconds. We get only around 8 milliseconds, because obviously the Android OS itself is running and it's like, what can I say, all the Android background processors, the other apps processors, and this view rendering stuff, and a lot of daemons in the Android OS, it's also running there. So we get only about 8 milliseconds. So think about it, if your code doesn't run in 8 milliseconds, that is when you see a jankiness in your app. That the sometimes when you see your when you scroll the app, it is not that smooth. Maybe it's like it's stuck in between and then it goes to the next frame. So these things all happen when you do very CPU expensive tasks in main thread. So that is the strategy for you to remember. Like whenever you're doing an expensive task, go to the worker thread. Worker thread is nothing but from the main thread you spawn another thread, and then you do your process there, and then you return the result to the main thread. So that is there. So mostly network calls, database insertions, IO operations, these are the tasks that we do in a worker thread. We don't disturb the main thread for that. Imagine if you're making an API call, and then like if you do that on the main thread, your entire UI will be frozen until you get an API response. It will take about 2 to 3 seconds to get an API response, and then you don't want the users to keep waiting till that. So that is the thing with worker threads. Again, how to do multi-threading? If you are brave enough, go ahead and create threads for yourself using executors, threadful executors, and post the runnables there, blah blah blah. It's like the basic Java thing. Like if you're brave enough, do that in Android. If you learn a lot, but if you really want to like do it like quickly and efficiently, you have to use libraries. If your project is in Kotlin, go with coroutines. There's nothing better than coroutines for Kotlin for multi-threading. It's the best, I'd say. If you're doing Java, then check out RX Java and RX Android. These both libraries go hand in hand. They are not different libraries. These both have to be used hand in hand, like goes hand in hand. So both have to be used. Check out RX Java and RX Android. It's for multi-threading, parallel processing, and whatnot. So it's a really nice library. You guys should check that out. And about background processing. So this also I was kind of confused when I was a student developer. There are a lot of ways that you can do a background processing, the background work. So how do you go about that? Before that, what is even background processing? It's like you do some task, some long running task that you want to do even when the user is not using the app, or when even after he leaves the app, you want to do some kind of processing. That's when you go into the background processing stuff. So the simple solution is just these three things should be fine in 2020. These things should be fine. You might find a lot of things out there, but I'm telling you, these three things should be fine. That is specifically alarm manager, which is in the middle. That's the rarest use case that you will ever encounter. But work manager and foreground service should help you with literally everything. So let me explain about these libraries. So we have work manager here. So apparently it's like a go-to solution for most of the tasks. This is my personal quote here. We could go-to solution. There are really a lot of solutions, but work manager is a go-to solution because the history behind work manager is that there were a lot of libraries before work manager which tried to do the same thing. For example, we had job scheduler, job intern service, and a lot of stuff was there. And then Firebase job dispatcher, and then the company Evernote made their own libraries, like I forgot his name. So they also have their own things. So this background processing was pretty messed up. And then Google came and is like, wait, let me stop the misery. I'll make one myself. So this thing is the go-to solution. It has a lot of features. I'll explain about that. And it's easy and reliable. Reliable is a very important word to mark here. Easy is obviously you just have to extend one worker class, and there's only one function which you have to handle in the callback, and then you just enqueue a work. And it's reliable because previously when we had to manually manage the background processing and all, we have to make sure that there was a lot of tricky ways that we have to make sure that whether our process is running or has it ran, or if your phone restarts, sometimes your process will not run again. Then you have to make sure that it has to run again. There was a lot of manual code that everyone has to write. So that is where this reliability thing was coming in, and work manager took care of it. So let me go with the features of these. uh, so basically you can start any task while you are in the app, and you can just like what can I say, yeah, it can run even when the user leaves the app. For example, imagine in case of multi-threading, you can do the same thing. You can start an app, but excuse me, there's my dad's phone ringing, I'm so sorry. huh. So yeah, what I was saying, if the user in case of multi-threading, when I was explaining over there also, you can kind of start a job, but start a process, but that process is going to end when the user leaves the application. So imagine like you start a thread, and then that thread is entirely closed when the application process is closed. But in case of a job that you're doing using work manager, it will continue even when the user leaves the app. It will complete only when it is like when the entire thing is completely finished. Also, you can start a deferred task. This is just a small thing. It's like you don't need to start a job immediately. Maybe after like 2 hours right now from now you want to start a task, yeah, you can set that in deferred task. And yeah, just setting constraints is really important thing. Imagine you want to do some like what is it, database cache, not caching, I'd say syncing with the backend, and you have to do it every night at 2 a.m. only when the user is connected to Wi-Fi and is charging his phone. So these kind of constraints, if you want to set, you can set it using this work manager like library. There is like scheduling and retry mechanism as well. If your job fails, you'll say what should I do if it fails? Should I retry or should I just leave it and like that. There are a lot of more features to work manager. I'm just telling you the basic ones. Like when the use case is right, you can explore more about work manager. So let me go into alarm manager. Alarm manager actually doesn't help you do long running tasks or something. It'll just imagine it's like a trigger to your application saying, hey, you wanted to do something at this time, so now it's the time for you to do it, just do it. So yes, exactly. So as the name says, alarm manager is for alarm type of things, like exactly at particular time. So one thing that people should keep in mind about alarm manager is that your your alarm manager receiver, it's a broadcast receiver. So when you receive it, then just on receive method, there is a CPU wake lock. So it's really important to understand what CPU wake lock is, because when alarm manager, like when you receive this on receive, when you get this callback on receive, your app might not be running in the background, like on the foreground, or even your device might be in this doze mode. That means you switch off the screen and then you get the phone aside. So when you're receiving a callback on receive methods in alarms receiver, probably a phone is not awake. So this Android OS takes care of it's putting a CPU wake lock until that function is executed. So you can do whatever you want to do in that function. Until that time, your phone is going to support you for that. That is fine. You can also do one thing. You can start a service from an alarm manager. Yes, you can do that. So even when the phone is like sleeping, you can still start a service. But one thing that you have to keep in mind is, now even that service have to have a wake lock policy for itself. That actually it's a what can I say, it's a long process. That, so just know that if by any chance you want to start a service from an alarm manager, you need to have a separate wake lock policy. So that's with alarm manager. There is another thing called foreground service. It's particularly important when you have like never ending tasks. Obviously you would think about battery draining and all, like never ending tasks. Can it even run all the time? Yes, it is possible. With foreground service, you can keep your like process alive forever if you're using foreground services. Yes, the example for this is obviously the media playback. So you keep listening to music even when the app is in the background and your media is just keep on playing. So that is the thing. And like for example, sometimes you want to build apps. Mostly in hackathon, I've seen a lot of people need to build apps which constantly keeps track of latitude longitudes, so that they can track someone or help with something or something like that. So there we have this you can use these foreground services. Foreground service is kind of different from a normal service in this way, like it has to show a notification always. there has to be a notification on the screen always, so that the user knows that something is running. So that is the thing with foreground services. Again, one big limitation is this OEMs, like this Vivo and Oppo devices, and this OnePlus, Samsung, and everyone. They impose their own battery saving options. So literally, it's very hard to keep our services always running. So for those kind of things, this is a very important link, don'tkillmyapp.com. Go there, and then you will find solutions for how to tackle these things. One, how to tackle different phones like Vivo, Oppo, and stuff, like how to handle those aggressive battery limitations and all. One silly thing that I saw here is Oppo phones can be easily cheated if you are running a foreground service. So you do something, you create something called a wake lock, and then for creating a wake locks, you set a tag. So that tag, you just name it location services, and that's it. Oppo phones cheated. It's like, oh, okay, fine. So basically, you're saying you're a location service and you want to run. Okay, fine, run. That's all. So there's a lot of things you'll find in don'tkillmyapp.com. So do check it out if you're trying to use foreground services, and then you find like it's not working in multiple devices like that. So coming to the last thing that I'd like to discuss is how resources, like how to keep you updated. These resources are not the learning resources. You have a lot of learning resources, but then I'm going to tell you the resources where you can keep yourself updated. First and foremost thing is blogs. Read a lot of blogs, definitely. That's going to keep you updated, like no other thing. So make it a habit to read at least one blog a day. Like when you have a lot of work, even make sure at least read one blog. Spend around 10 to 15 minutes, learn one thing newly daily, and then by the end of few days, you'll be surprised how much you have learned through blogs. So these three things should be fine for blogs. One is the Android developers official blog, and then there is two other publications called Pro Android Dev and Android Pub. So these things should be fine for blogs. There are a lot of blogs coming up every day. So just read the ones just that piques your interest, and at least know the topics that are coming up, so it might be useful for in future. And it's important to keep yourself updated by looking at a lot of conference talks, attending talks. Yes, good thing, but also some previous nice very like cool talks are there in droidcon.com. Please do check it out. Like I've personally learned a lot of things from there. Like it's very valuable resource there. And if your YouTube is obviously the very obvious choice over here. So YouTube, there is official Android developers channel, and then there's also a few droidcon channels in YouTube itself, so you can check out the talks over there. So if you're into podcasts, so I would highly recommend you listen to these three podcasts. They have really good content, especially the Fragmented podcast. It has a lot of episodes, and they have really cool guests, and they discuss all interesting latest topics. And Android developers backstage is the official Google's one. Like the people from Google are handling this podcast. Android Idiots is some Indian guy, so I don't know, I just added it. I listened to it, so just added that. So listen to at least the first two ones if you're really interested. That's all about those and things. Other resources are probably, if you're free and then you want to browse your phone, check out Reddit, Android Dev subreddit, and Kotlin subreddit. There's a lot of stuff going on there. You will learn a lot. Just go through it, even if you don't understand. Just see what people are talking there in your free time. And in Twitter, go follow Google Developer Experts for Android. There are a lot of people. I could have listed it here, but I thought maybe if you just search for Google Dev Experts, you'll get a lot of people. Follow them in Twitter. There's a lot of fun going on in Twitter. And finally, if you want, you can subscribe to newsletters every week. That you'll get a collection of articles that and videos and everything in your inbox email. So this is how I keep myself updated, and then just sharing with you. So that is all from my side right now. And I'll follow me on Twitter. I'll post the link of slides. Wait, like I'll put the slides over here in Twitter. 1 minute, I'll just show my Twitter ID. So yeah, I forgot to add the slides link over here, so I thought I'll tweet about it, and you guys can check that out. Now, moving on to any questions that you guys have, I'm like very much here to answer that. Yes, so I got this question. What are your thoughts on Jetpack Compose? Well, Jetpack Compose, I'll say it's very primitive. So keep experimenting with it. So Google is really trying hard to, push it more and then make it into the common man's practice and everything. Just explore that, but I'd say that is not what you would use it in a company or something, at least for the next few years. But it's a cool thing to explore, yes. But and meanwhile, you should also understand the Android's view system itself, like how this view work, how this view groups work, and try to create some custom views. Play with that as well. Just telling you. Navigation components, of course, yes, it is used even in Zomato. We use that in the restaurant app. I work in the restaurant app team, and we totally use the navigation component only in that. Yes, navigation components are used. It's pretty stable now and it has a lot of new features coming up as well, so it's a good thing for as well. Is mvvm answer to all app designs? Obviously not. Definitely not. Mvvm is something that Google suggests maybe you can use this, but there are a lot of places where mvvm is very cumbersome. You might need to check out some other architecture. For example, there's something called mvrx, and there is, I forgot one. Yeah, so I mean, it depends on the company that not company, I should say, the problem that you're really trying to solve. If you're trying to push an mvvm into everything, then you might be limited on how you can solve particular problem. What I mean by problem is because for example, in Zomato we have a server driven architecture where literally every data which is rendered on the screen is coming from backend, like even the color, even the text. At that point, we used to have only one recycler view for the entire screen. We have no views at all, just one recycler view in the activity, and that's going to render everything. In that case, the mvvm was not the right fit for us, so we had to get in, what to say, kind of a mixed architecture between MVP and MVVM. So there was a hybrid architecture we had to come. So what I'd say is, don't stick to one architecture. Keep exploring a lot of architecture just so that you get an idea about what to do and how to proceed with how to solve those problems and all. So what do you think of motion layout? Cool stuff. Please do check it out. We even started using in our app lately. Motion layout is really cool and it's very easy to work on. Now that we're getting amazing support in like Android Studio itself, please do check out motion layout. It's such an awesome thing. Because without motion layout, the animation that you could do with motion layout is really hard. Now that you have done it, it's so nice. Like, I'm very grateful that something called motion layout came out. And but one limitation we had with this thing is in specifically my company, for some reason they would never use constraint layout. Apparently it's like a very expensive layout. At least they said they did some metrics and found out that constraint layout is a very expensive layout, so they would try to avoid it how much ever possible. Only in very worst cases we use constraint layout. So it took some time to convince people whether we should use motion layout or not, but apparently we ended up using it. Nice. Do we need to be well versed with CI/CD? Yes. So if you are planning to go into platform team of a company, please do know about CI/CD. Mostly as a developer, you don't need to do that. It's like if you're an individual developer getting started, don't worry about CI/CD right now. Just what can I say? It's like just understand that it's how can I put it? if you're managing a larger teams and if you want a perfect workflow and if you have a lot of tests that you have to run, or maybe there's a lot of uh, checks that you have to run before merging someone's code, and there's a lot of stuff that if you're running a larger team, and that's where really CI/CD helps. So don't worry about CI/CD when you're a student. Even when you go to a company when you're a fresher, unless you are asked to work on CI/CD, you don't really need to worry about it. It's actually an icing on top of cake. So just know how to make a cake, and later you can work on CI/CD so that it acts as icing on cake. That's the thing with CI/CD. Things that will transform the app dev. First thing, as the Jetpack Compose is coming, so obviously the UI part of it, it'll just like the way we think about creating UI is going to change for Android developers at least. What else can I say about future of Android dev? See, if you want to know about hybrid stuff, if will it take over the native stuff or something like that, might not really work that well. Hybrid stuffs are coming, but I can't really say. As of now, I can say hybrid stuff might not take over native stuff. It's good to know hybrid stuff like Flutter and React Native and whatnot, but native stuff is still going to say. And for future, I don't have much to think about. Let's stay in the present for now, though. Splash. Are fragments always destroyed when the underlying activity is destroyed, like holding activity reference in fragment? Is it bad? Yes, it is detached, but the views are destroyed. I am not really sure about this question. You might have to explore a bit more. I guess it is destroyed. Yeah, that's a good question. I'm not sure yet. Fragments always destroyed and underlying activity. So don't yeah, you can hold a fragment reference inside activity. That's not going to be an issue. You can use it. Like for example, you might need that fragment for making a different transaction later. We do use that, so you can. I don't think that's a bad thing. Okay, MVI and clean architecture. Yes, MVI was the word I was searching. At what scale of project do they justify writing so much boilerplate for implementing them? So as you say, it's so true that in your side projects, don't like side projects. By what I mean is, if you're doing a project where you have less than like about 10 to 20 features or less than 30-40 screens, so going through that pain of implementing clean architecture and all that boilerplate and the ceremony that you do with other stuff, that to MVI architecture, it does have a lot of things to do with it, like for setting it up and all. So I'd say you should explore that. Doesn't mean you have to follow that in all your projects. Just make one project just to see how it works really, like just to understand that. Or you can read a blog, and if you can understand that, that's fine. But it'll be great if you can also test it in one side projects or something. It's so nice. So again, I'm telling you, you should explore stuff, but then you shouldn't stick to architectures. Think of it this way. It's like you explore a lot of stuff so that you know what are all present and you use the right ones in the right situation, like that. Just when you're learning architecture, see what problems they solve. Specifically in Mvvm, they handled a very important thing in Android for orientation changes. So like that, see how that other architectures are handling that, and get to understand those things. That'll help you. What's the best way to implement ML in apps? Move it to the backend, bro. We have done a lot of things in Zomato itself, and even in my student life, I have experimented with ML a lot. So if you want, you could use the latest Firebase ML kit or something. So if that seems to be a promising solution, although personally I haven't tried it, but always it seems like moving ML stuff to the backend was the best solution for us, because in Android by default it only supports TensorFlow Lite models, and mostly when people I worked with, when they give TF Lite models, the accuracies are reduced, and also the app size is increased because the model has to go with the phone, and it add a lot of limitations. So if you want, probably you can check out Firebase ML kit, or ask drill your backend guys. Best way to design UI of Kotlin app. Uh, this question actually it's a bit confusing. Best way to design UI is to first ask a designer if you know someone, or check out this website called Up Labs. I've sent it in the chat. So you can check out this website called Up Labs. By the way, there is a small delay. If you get a response in the chat right now, my audio will be coming like at least 1 or 2 minutes with delay. So you should check out Up Labs if you want to get some design insights, or you should ask a designer you know. Of Kotlin app, I am really not getting that question, bro. There. Yes, exactly. Server driven dynamic UI, every single text, the color of it, it gives us so much that we even have to, I mean, the click action of a button is also coming from backend. Doesn't mean they give the lambda for us to execute. They'll say what type of action to be performed on this button click, and they even send colors for both white theme and dark theme as well. And like literally the entire layout is controlled by the backend. So we have this thing in Zomato called universal RV adapter and view renderer concept. I'll just type it in the chat. You will get it even before you get this audio. So we have this thing in Zomato called view renderer. So basically every single snippet that we create reusable views, and then as and when the backend says, hey, now at this position you have to render this view, at this position you have to render this view, we put in views over there, and then we inflate it using the data given by the backend. And yeah, pretty much everything, the app is as dumb as possible. Everything is controlled by backend. Even the tracking is backend by controlled by backend. Tracking in the sense, like when you swipe and when you click on something, when you how much time that you spend on one page and everything, those things, even those kind of things are controlled from the backend. So I guess that's about everything in my presentation. If you have any like questions, probably you can ping me in like Twitter or something, Twitter or LinkedIn. I'll be happy to help you there.